Hello students, I hope you all are doing fantastic out there. So we are doing exercise 7, laws of indices, isn't it? So we have completed till question number 8 in our previous videos. Now today we'll start from question number 9 onward. Okay, so let's begin. Question number 9, we have a equals to x to the power m plus n into y to the power l, and the value of b is given x to the power n plus l into y to the power m, and the value of c is given to us x to the power l plus m into y to the power n, isn't it? So we are asked to prove this. A to the power m minus n into b to the power n minus l into c to the power l minus m equals to 1. So we are asked to prove this, isn't it? So let's write LHS equals to, the question is very simple but a little tedious one, okay, little boring. A to the power m minus n into b to the power n minus l into c to the power l minus m. This is what we have in the left hand side, and we are asked to prove this equals to 1, isn't it? So let us put the values of a, b and c. A means x to the power m plus n into y to the power l. So instead of this a, I write this whole thing, okay, because a means this thing, isn't it? So x to the power m plus n into y to the power l. This is a, isn't it? This is a. So a to the power, let me put curly bracket, okay, a to the power m minus n, we have the power m minus n here, so we should not forget this power. Now again into b to the power n minus l, isn't it? So let's put the value of b. B means this thing, isn't it? B means x to the power n plus l into y to the power m. So instead of this b, I write x to the power n plus l into y to the power m whole to the power, and the power of b is n minus l, isn't it? So n minus l into c to the power l minus m. Now what is c? C is x to the power l plus m into y to the power n. So I write, instead of this c, I write the value of c, okay, x to the power l plus m into y to the power n. This is c. So c has power l minus m, so we should not forget the power of c, that is l minus m. Now this power m minus n is for both the numbers x and y, because both the numbers are within the bracket. So let's put this power individually, okay. Let me start from here. X to the power m plus n into this power m minus n into y to the power l into this m minus n, isn't it? Are you getting me? This power m minus n is for both the numbers, so this x has already m plus n here, so I put m minus n. So y has already l power l here, now I put m minus n. I am putting this m minus n power to both the numbers individually, okay. Now let's do this. Here also the power of x is n plus l and the power of y is m. Now this power n minus l is for both the numbers, so let's put this n minus l to both the numbers individually. X to the power n plus l into n minus l, isn't it? Into y to the power m into n minus l. We must be very careful with the sign, okay. We should not forget the sign, otherwise the answer will come wrong. Now the power of x is l plus m. Here l minus m, this l minus m goes to both x and y. So x to the power l plus m into l minus m. So y to the power n into this l minus m. Because this l minus m is for both the numbers, so I put this here and this here as well, okay. I hope you got this. Now x to the power a plus b into a minus b, isn't it? M is considered as a and n is considered as b, okay. So a plus b into a minus b gives us a square minus b square. We know the formula, isn't it? So y to the power, let's multiply this l with m and n. L into m is lm, plus into minus is minus, l into n is ln. ln, okay, into x to the power a plus b into a minus b. You can see here, so n is a and l is b, so a plus b into a minus b is a square minus b square, isn't it? So y to the power m into n, let's multiply this. M into n is mn minus m into l is ml, into x to the power, now we have a plus b into a minus b, that is a square minus b square, isn't it? So y to the power n into l is nl minus, this minus comes here, n into m is nm. Okay, now we have x, x and x, same base, isn't it? So their powers will be added, isn't it? So x to the power, here we have m square minus n square. If the bases are same, then the power will be added. So x, x and x, so their powers will be added, okay? Here we have m square minus n square plus the power of x here is n square minus l square, n square minus l square, plus the power of x this l square minus m square, isn't it? Now we write into y. So y, the same thing, isn't it? Power will be added, the bases are same. So lm minus ln, lm, this lm minus ln minus ln, isn't it? This is n, okay? And this is plus mn minus ml plus nl minus nm, isn't it? So this is plus m square and this is minus m square, can be cancelled. Minus n square plus n square can be cancelled. Minus l square plus l square can be cancelled. So x to the power 0 into y, isn't it? Y. So this is plus lm, isn't it? This is minus lm. ml or lm is same thing. 2 into 3, 6. 3 into 2, 6. The result is same, means either you write 2 into 3 or 3 into 2, doesn't make any sense, isn't it? So same thing, lm and ml, same thing. So plus lm and minus lm, they cancels out each other. Minus ln and plus nl, same thing, isn't it? So they cancels out each other. So plus mn minus mn cancels out each other. So y to the power 0. So I told you earlier, anything to the power 0 is 1, except 0 to the power 0 is not 1. 0 to the power 0 is undefined. Other than 0, any number raised to power 0 is 1. So x to the power 0 is 1 into y to the power 0 is 1. So 1 into 1 is 1. So we have 1 in the right hand side, isn't it? We are asked to prove this equals to 1. So this equals to RHS. Hence proved. I hope you got this. Now let's do question number 10, okay? To question number 10, simplify. This is question number 1 of 10, okay? Sub number 1 of 10. We are asked to simplify this expression. So let me tell you, if we have x to the power a upon x to the power b like this, we can write this as x to the power a into x to the power minus b, isn't it? This power plus b, when goes to the numerator, changes to minus b. So the bases are same, x and x, the powers will be added. So a plus minus b, isn't it? So this gives us a, plus into minus is minus, so b. So this gives us a x to the power a minus b. Okay, I hope you got this. X to the power a upon x to the power b means x to the power a minus b. Now let's do this. X to the power a upon x to the power b means x to the power a minus b. Okay, this plus b goes to the numerator and becomes minus b, into we have a square plus ab plus b square. So here into x to the power, this can be written as b minus c whole to the power b square plus bc plus c square, isn't it? Into here we can write x to the power c minus a into c square plus ca plus a square, isn't it? This is bracket, okay, not c. So a minus b into a square plus ab plus b square is actually a cube minus b cube, isn't it? The formula for a cube minus b cube is a minus b into a square plus ab plus b square. We know this, isn't it? We have learned this in class 8. So x to the power a minus b into a square plus ab plus b square can be written as a cube minus b cube, okay, into x to the power here a minus b, b is a and c is b, okay, a minus b into a square plus ab plus b square means a cube minus b cube into x to the power c is a and a is b, okay, a minus b into a square plus ab plus b square means a cube minus b cube, isn't it? So x, the bases are same, their power will be added, isn't it? So x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. This power is this power is this, and this power is this. We are adding all the powers because the bases are same, x. So this gives us plus a cube and minus a cube cancels out, minus b cube and plus b cube cancels out, minus c cube and plus c cube cancels out, x to the power 0. So any number raised to power 0 is 1, isn't it? Except 0, okay? So this is 1. 0 to the power 0 is not 1. Please keep this in mind. 0 to the power 0 is undefined. Other than 0, any number raised to power 0 is 1. So the value of this expression is 1, okay? Now let's do question number 2 of 10. Okay, let's do question number 2 of 10. This is the last question from this exercise, isn't it? So let's simplify this. We are asked to simplify this expression. So I told you earlier in question number 1 of 10, x to the power a upon x to the power minus b, isn't it? We have this. So this means x to the power a into, if you take this x to the power minus b to the numerator, the sign of the power changes to plus b, isn't it? Minus b becomes plus b if it goes to the numerator. So x and x same thing, the power will be added, a plus b. You can write this number as in this form, okay, x to the power a plus b. So this gives us x to the power a plus b whole a square minus ab plus b square, isn't it, into x to the power b, so minus c goes to the numerator and becomes plus c whole b square minus bc plus c square into x to the power c plus a, isn't it, c plus a, minus a goes to the numerator and plus a into c square minus ca plus a square. So a cube plus b cube means a plus b whole a square minus ab plus b square, okay. This formula we know, we learned in class 8, isn't it? A cube plus b cube means a plus b into a square minus ab plus b square. So if you know this formula, I hope you know this formula, so we can write this as a plus b a square minus ab plus b square as a cube plus b cube, isn't it, into this as a plus b into a square minus ab plus b square, it's a cube plus b cube into x to the power a plus b into a square minus ab plus b square means a cube plus b cube, isn't it? So the bases are same, x, x and x, so power will be added, x to the power a cube plus b cube plus this power b cube plus c cube plus this power c cube plus a cube, isn't it? Powers will be added because the bases are same. So this gives us x to the power a cube and a cube plus a cube plus a cube 2a cube plus b cube 2b cube, isn't it, plus b cube 2b cube plus c cube 2c cube. So x to the power, here we have 2 and 2 common 2, so we take the common out, within the bracket remains a cube plus 2 is taken out, so b cube plus this 2 is taken out, so c cube. So this is the answer for question number 2 of 10. I hope you got this. Please take the screenshot. Thank you so much for watching this video. I hope you understood the concept, laws of indices from exercise 7A. Okay, we'll continue the 7B in the next video. Until then, stay happy, stay blessed, and continue practicing. Unless you practice yourself, unless you work hard yourself, you are not going to learn. Okay, you practice yourself, and if you find difficulty in any question, then you come back to the video, watch that video again, and then practice yourself. Okay, practice makes a man perfect.